such a nice evening of talks. I hope you had a wonderful summer full of trying, wild flings with all kinds of other JavaScript frameworks and tools. Now you're back here to learn about what's been going on with Ember. This is exciting. So, my name is Matthew, in case you need anything, helping us organize here tonight. I'd like to thank, first off, Cardstack for hosting us here in this awesome space. There's a great view out the window, which you should look at even after the sun is down. It's pretty cool to be able to see all the way across to New Jersey. Look. Some things that are coming up in the Ember community that you might want to take a look at. Emberfest Copenhagen is on its way. Let's take a look here. Ooh, October 17th, so soon. Is anyone going to Emberfest? Anyone here? Cool. Yeah. Jen's going as well. Jen hasn't made up her mind yet. Last minute decision. Big decision. Copenhagen. Wow. Another thing, if any of you want to jot it down quickly, or maybe I can tweet out this link, our friend of the Ember community, Jordan Hawker, wrote up some great notes from Ember Camp, which happened, I guess, a week and a half ago in Chicago. There's great notes here that go through all the talks that were given. He has links to all the slides that people had and things like that. It was a really neat event with a bunch of both Framework Core team members, a bunch of people from New York being represented. Spencer gave an excellent talk in which he had my favorite slide of the entire talk, the entire day, and it said, "In defense of the ideas we filter," which was great, nice inspiring phrase, trying the things that you normally block out. So I was really inspired by his talk. You should give it a look once the videos are up, and I think the video should be up this weekend, is what Mel said. Ember 3.13 was released a few days ago. That's pretty exciting. Ember 3.13 contains all the features in Octane, so Chris is going to talk about Octane tonight, and all the things that he shows you can be used on their own, or I guess if you use the flag, then you could use all of them as an Octane edition. It's pretty exciting, so good time to try 3.13 on your existing apps without using any of the new APIs and make sure that there's no regressions in the existing stuff, and then look at migrating over to the new stuff through the 3.13, 3.14 cycle. And just some other upcoming things. We're going to be movable ink, so look forward to that next month. And Ember Octane is going to be coming at the start of.
Yes, Octane!
Yeah.
Woo!
Yeah. This is
#1.
This is your opportunity to finally use all that Ember knowledge that you've been building up for all this time to go and speak at a different meetup. This is your opportunity, so I encourage you to try and take that up. Okay, tonight we're going to, just to give you a quick idea of what's going on, Chris Garrett's going to talk to us about Ember Octane. Hassan is going to speak to us about Ember Concurrency and the blockchain. And Ed is going to talk to us about compiling Ember. That sounds pretty wonderful. Chris, if you'd like to try and get set up here, I'll maybe open the room for announcements. Chris, would you like to maybe start us off with announcements?
Sure. Why you set up? I'll come. Hello. Okay. I'm Chris C. I am the founding director and lead of the Cardstack project. This is our office. Welcome. Glad to be able to host the Ember NYC event here. It's not a big space, but I think it's good to have a community that know each other, and seen so many familiar faces. For those familiar with the work that Ed, myself, Hassan, Jen, and many other people have been doing, we're building basically a full stack framework that uses Ember and Octane on the top, and then figure out how we take all the things that we love about Ember and go down the stack and find something that just works. The goal here is to create what is essentially a SaaS platform that's 100% open source, so you can use Ember as your templating layer, as Ember data, maybe Orbit as your thing, and define your schema, and then everything just works. It searches, it composes, you can extend a template, you can drag and drop new fields, kind of like what Salesforce.com does, but open source, and deploy on your own server. I think that's a really important way to level up one level further, instead of having everybody say, I do front end, and then figure out what else is going, to see if we can take the conventions we like and actually complete the stack. So that's Cardstack. Card is a metaphor on the UI front end, but also as a way about mobile data, making app more like content, saving versions of them so you can boot them back up. Tom and I have been talking about this for literally 7 or 8 years, even predated some of the early version of Ember of can we build something amazing with JavaScript, the web platform that allow apps to be more like manipulated by end users. So we're getting close to that, and hopefully with Octane even creating a greater ramp. So glad to be here to share. Hassan will be sharing some of the work we do on the blockchain stuff, decentralization, but it's all related to the type of idioms that we like, and hopefully adds up to something that opens up new gates for people to be awesome again and empower the next million creators, as we have given previous talks on that. So that's me.
Any other announcements before we give Chris the floor? I'll say one more announcement. The company that I work for at Apar is hiring for front-end JavaScript developers, people who know Ember. We use a pretty classic version of Ember right now, Ember 1.13. Yes, it's vintage. It's aging very well, just like you, Tom. Okay, but there's a lot of other interesting projects going on that are using Octane and other things like that. So please feel free to talk to me later tonight. And with that, Chris Garrett is going to talk to us about Octane. Thanks, Chris.
Direct, he's ready. Yeah.
How's it going? So yeah, today I wanted to talk specifically about the Octane upgrade. I've done a few small talks and also written some blog posts about the actual features that are coming out in Octane already, but we've also been really focused on how people are actually going to upgrade their apps, because it's a little bit of a different thing than your standard like minor version, major version bump in a framework. So, but first up, a little bit about me. I'm Chris Garrett, actually. That is a recent addition. I just got married in May. And pretty much everywhere online, I am known as Xerox. Like 99% chance if you see that, it's me. And
I thought it was your last name. Really long time.
yeah. Funny story, actually. The way that I came up with it was just typing random letters in Google until one had no results. So, yeah. And then, yeah, I'm an Ember core team member, and I currently work at LinkedIn. So, first off, just in case, has anybody here not heard of Octane? No? Okay. Well, I'm just going to give a quick overview of what it is, just in case. So, Octane is Ember's first edition. And what that means is, like, it is a new programming model. It is a set of features that we've been working on and progressively shipping over time in various minor version releases of Ember. But they're all really meant to work together, and so we couldn't really recommend that users adopt them until all of them had shipped. So really, that's what it's all about. And it's also about doing it in a way that is backwards compatible entirely. We didn't want to release, Ember never has released a major version that completely changes the world, that rewrites everything, and forces you to rewrite your entire application. That's kind of antithetical to Ember. So yeah, it comes out in 3.14, like Matthew mentioned, and all of the features in it are available in 3.13 currently. So those features include Glimmer components, track properties, modifiers, which are a new top-level kind of primitive in Ember for interacting with the DOM. Angle bracket syntax, which is like a much nicer, in my opinion, way of looking at components or viewing or writing components and reading them. And then on and fn, component co-location, and native classes. So at a high level, this is a new object model, native classes, which completely replace Ember Object and all of its features. A new component model, Glimmer components, which replace classic components that we have written for a very long time now. A new DOM interaction model, which are through modifiers, and like the new built-in modifiers. And a new reactivity model, which is what track properties are all about. It also includes a number of optional features. So there are a few hard-breaking changes in Octane. They are all opt-in, so they are something that you can slowly turn on in your application as you work through the upgrade process. Our recommendation, as you'll see in a minute, or my recommendation rather, is to opt into those early and try to figure that out, but yeah. So let's get into how to do this upgrade. Disclaimer, there is no one true way to upgrade. This is just a plan that I have thought out with a few other community members, and if something is unique about your application that makes you want to tackle it in a different way, feel free to do that. Like, these are just general guidelines. It's more like the Ember deprecation workflow, just a way to slowly, to kind of think about how to plan for this upgrade. And so the way that I think about it is a normal Ember upgrade, first and foremost. You bump to Ember 3.13 or 3.14, and then you opt into these behavioral changes, these breaking changes, one at a time, and fix whatever issues are there. Most of them, by the way, are relatively small and code moddable. I'll talk about them in a minute. And then you have a set of idiom changes, and this is the real meat of the upgrade. This is the portion that will probably take the longest. Like I said earlier, these are the high-level object model, component model, DOM manipulation model, and reactivity model changes. So my recommendation at the moment is to approach this as a two-phase upgrade. Phase one is actually something you can start a bit early. You don't have to get all the way to Ember Octane, and for a lot of people, that will be very valuable. Like, you might be stuck on an earlier version of Ember in a very large application where it takes quite a while to upgrade. So you can actually start on as early as Ember 3.8 with polyfills. During this phase, you opt into the breaking changes, you upgrade to a recent enough version of Ember, and you introduce a number of new features, but they're mostly syntactic changes. They don't really change the meaning of the code that you are writing. They change the way that you write it. So let's dig into that a little bit. Like I said, the first thing you do is you opt into the, or upgrade to the target Ember version that you chose. I'd recommend one of the LTSs, so 3.8, 3.12, or Octane itself, 3.14. And then let's step through the various, and then you install the polyfills. So these are the various polyfills you might need. This is the only one that hasn't been written yet, and we're still working on it, but it should be available soon. And you really only need these polyfills if you are on 3.8, 3.12 and up, you're good. So then let's step through enabling the optional feature flags. The first one is implicit application wrapper. You may not know about this actually. It's just kind of an implementation detail, and except for when it isn't. But for the longest time, there was a div or element that wrapped your application. And so this flag turns that off. And if your app relied on that behavior, you may need to update a few things, but most apps actually don't in practice, I believe. The second one is jQuery integration, and this is important to note. It's not about completely removing jQuery necessarily. If you're still using jQuery and lots of jQuery plugins and stuff, this is really just about getting getting rid of this $$ sign and like other parts of the event dispatcher. That was the other part of its integration into Ember. So you can flip this flag and install Ember jQuery and bring back jQuery as a whole. So you can continue to use it if you really want to. The next change is template-only Glimmer components. So by changing this flag, you are actually opting into a different behavior for template-only components. They actually will be backed by a Glimmer component, by Glimmer components behavior, which is pretty different than classic components. However, this isn't going to break your app. Flipping this flag also runs a code mod that creates a class, just an empty Ember component class file for every single one of your template-only components. And then you can move on from there and start to upgrade individual components to Glimmer components and template-only Glimmer components. And then finally, async observers. So observers today run immediately whenever the property they are observing or the chains of the properties that they are observing change. This change makes them, by default, asynchronous. And you can opt back into the sync behavior if you need it, but in general, it's a good practice to write your observers in a way where you don't necessarily know when they're going to run, and have them be idempotent and whatnot. So, yeah, this one, if you're on an earlier version of Ember, it may make sense to not toggle it just yet until you get to Ember Octane, primarily because one of the reasons observers still exist in Ember is for certain use cases that couldn't actually be solved until recently. So like here is like the canonical example of this. You have a helper, which you've defined, a class-based helper, and you've injected a service into this helper. And you have an observer that watches some value on that helper, or on that service rather, to cause the helper to recompute, to invalidate. And this is actually not required anymore in Ember Octane because auto-tracking will track that access of that value when you compute the value of the helper. So there's no need to have an observer anymore. And we believe pretty strongly that most use cases of observers have been filled with auto-tracking. So at this point, we expect people to start migrating off of them entirely, ideally. We'll see. It's one of those things that it feels like it never dies, but cool. And so that is the end of that phase. The next step is to run the code mods. So the first code mod that we have converts you to angle bracket syntax, basically uniformly throughout your app. It's important to note that this does not convert you to using named arguments within your components. That is something that can't actually be code modded because they have slightly different semantic differences or meanings than actually referencing arguments not using the @ symbol. But the key thing to remember here is that angle bracket syntax works with classic components and with Glimmer components, with any type of component. And it really is just a different way of writing curly bracket syntax. It is one-to-one. So that conversion can be fully automated, and that's the first syntactic change. The second one is the implicit this code mod. As part of Ember Octane, we are removing the ability for, or deprecating, I believe it will be technically removed when strict mode actually gets finalized. But removing the ability for you to access properties on the context of your template without using this at the beginning of those properties. This is an interesting code mod because it actually has to run and gather data from your application. So you have to boot up your application to run it and point it towards that. And that's because it needs some runtime information about what helpers you have and whatnot in templates. But other than that, it should be pretty straightforward. I believe both of these are almost, if they aren't ready, they will be very ready soon. They have had a couple of kinks around the exact spacing of the output being off and then causing issues. So that has been something that people have been working on. Another code mod that is in progress is co-location. So we expect this one to be pretty straightforward. It's basically just moving the files from your app / templates or / components file to the components directory directly. So, and then finally, we have the native class code mod, which is definitely going to be the largest one of all. And like the implicit this code mod, this one has to run against your application and gather a lot of data about the classes themselves in order to be able to correctly convert them. However, we've had a lot of great success with it. I was able to run it against emberobserver.com, which converted and passed all tests. So there are occasional still edge cases that we have been catching. So if you run it and you run into issues, please let us know, open up issues. We want that to be as smooth as possible. And one particular missing thing right now is it does not convert data models. We just haven't finished that part up. and we were kind of hoping to wait on the Ember data module, like import stuff being finalized a little bit, but yeah. And then after all of that, you should take a moment to breathe. You're gonna have just made a massive amount of changes to your application, and really, like, it can be very frustrating for me when, you know, I've learned how to do things in a particular way, and then I get back into my, you know, development flow, and I'm like, oh yeah, things have changed. The file is now over here. I now have to use this new syntax. I would definitely recommend learning all of the differences, because there are subtle differences. For the most part, they're pretty one-to-one, but there are a couple of changes, like the way that class fields get assigned. We have guides for this on the official guides, and we're definitely trying to make sure that that part is pretty smooth. But learning all of these, I think at this point, before you dive into phase 2, is very important. And then another thing that you can do in phase 1, you don't have to necessarily complete it in order to move on, but I'd recommend getting started at the very least, is working through the classic decorator workflow. So when you run the native class code mod, the classic decorator is going to be applied to every single class that it converts. And basically, you can use it as an indicator that this class either has some work to do or is using some classic features in general. I'll talk about what that means in a moment, but in general, it can be removed from all the routes, controllers, services, and helpers in your application, but it cannot be removed from classic components. Part of the reason for that is because classic components are pretty tightly intertwined with the old object model, so we don't want to mislead people in thinking that they work. Yeah, there's issues with it. And then the other reason, though, I think is much more pragmatic, and one of the initial issues we encountered with Glimmer components and classic components living together in the same code base, you're going to be looking at a lot of classes that look very similar at first glance and have a lot of similar functionality, serve the same purpose, but are very subtly different in different ways. So the classic decorator is meant to be an indicator that this is a classic thing, that it is a classic component. It is not a Glimmer component. And that's meant to very quickly, at a glance, tell you what you need to know about what you're working with. The other thing that you can't convert are utility classes, and I'll get to that in just a second. So this is what a controller with the classic decorator might look like right after being converted. You can see we're using the init method, which is similar to constructor, right, in objects. And we're using this.get, this.set. And this is what we mean by removing those classic APIs. As you can see, we converted to using constructor, but we're still using get and set. That's not something that you have to remove necessarily. We're just talking about removing the method calls themselves. The long-term goal here is to be able to get to a place where you can actually drop Ember object as a whole. The methods that it provides, the functionality that it provides. So using the functional forms of these things is still completely okay, because they've always worked with like POJOs and whatnot. And same with computed properties. And utility classes, when I say this, I mean any kind of class that you defined that wasn't a framework object. Like oftentimes in an object-oriented language, you define classes, you use them for various things. So in general, when you encounter something like this, we're not going to let you remove the classic decorator outright, because the recommendation is to actually convert that to just a plain class. The only reason you were using Ember object in the first place was because you didn't have class syntax. So at this point, it really makes sense to define the class as it is. You can still use computed properties. You can still use get and set. But the methods that Ember object provides and other functionality that it provides is something that we don't want to keep using in general. There are a few other refactors you can do at this stage. You can remove any remaining observers if If you can replace them with auto tracking, I definitely think it would be a good idea. Also, Ember event listeners. In general, Ember doesn't really use eventing that much internally anymore. Certain parts of the router do a little bit, but not like, it's not nearly as crucial as it used to be for the framework. So there actually is a deprecation RFC at the moment that has been having some discussion happen on it, and we'll see where that goes. But in general, I would recommend moving away from them and potentially using a third-party library for eventing. There's like Event Emitter 3 on NPM and whatnot, or you could use RxJS. And then the last thing would be removing mixins in general. They actually, I believe that the classic decorator will kind of require you to not use them anymore. The main reason we haven't provided a native equivalent for mixins is because we don't want to step on the language's toes again, like we did with class syntax. There's actually a TC39 proposal for a mixin-like syntax and for another syntax that would, like piping, that you would be able to write very mixin-like things with pretty easily. And another one for protocols. So there's a lot of things that are coming through the pipe that could provide this functionality in a native way. And in general, we want to like discourage people from trying to do metaprogramming that the language is going to replace. If you really do need a mixin, though, in the meantime, you can still use class decorators. I recommend trying to refactor to other patterns before you do that, such as just utility functions that are shared or service. But if you have to, class decorators work, or you can just use functions. You can have a function that receives a class and returns a mixed-in class, which is really what class decorators do anyway. So, cool. So that's the end of phase 1. Phase 2 is you have to actually get to Ember 3.14 for this phase, so actually get on to Octane. And this is mostly where there are large mental model changes. This isn't just getting used to a new syntax that means the same thing. This is actually going to mean major changes to your application. So Glimmer components, track properties, and modifiers all come in a big way at this stage. And the recommendation here is to refactor one component at a time and to do all of them at once per component. In order to do any one of these refactors, you're going to have to actually load up the entire context in your head and understand what your component is doing. So it doesn't really make a lot of sense to go and do all of that for track properties and then come back at a later date and do it all for Glimmer components and so on and so forth. Now, if you have a big component that is like very hard to break out into, like to do all of this at once for, you can still, like I said at the beginning, these are recommendations. It's not necessarily hard and fast rules. So feel free to just turn one or two things into a track property, to refactor one or two things at a time as it makes sense for you. But in general, you shouldn't try to like apply, I guess the main thing is don't apply these refactors across your entire app one feature at a time. Don't just go and make everything track properties and do no Glimmer components, do no modifiers. You're gonna want to like be progressively integrating all of them. Okay, so I also wanted to talk a little bit about some of the early gotchas that we have been experiencing as people are upgrading. So one of the first ones, track to getters don't cache. So that means if you're returning like an object from a getter, it's not going to be the same object. Every single time it's going to be a new object, and that's going to be important. If you need some sort of caching behavior, we don't currently have that built in, but you can just set it on the object, create your own caching pretty easily within a getter, like, yeah, this dot underscore foo equals the object, and then return that every time. So that's one important thing. Another thing that can happen, and this is, I think, specifically related to that fact, is you can get infinite tracked invalidation loops. And these usually happen because you returned an object, a new class, in a tracked getter, and then you immediately invalidated it. And you might ask, like, okay, when would I ever do that? When would I like make something and then update it? Promise proxy was like the first thing we encountered that did this. It made a promise and then immediately updated that promise. And in the creation of the promise proxy, it accessed the track property, or the computed property in this case, auto-tracking it, and then caused it to immediately invalidate its own cache on the next run loop. So it's just something to be aware of. We're working on tooling to make it more apparent, both how tracking works, like what you are tracking, what caused the previous invalidation, et cetera, but also to help catch these kinds of things. So just something to be aware of. Another thing is, like I mentioned earlier, make sure you know what kind of component you're working in. Technically, the classic decorator is optional. If you install it, it will try to enforce itself and like try to get you to put it on everything. But some people might choose to upgrade without it, and if you do, just be careful. Maybe that's a classic component, maybe it's a Glimmer component. Another thing is don't just use Ember render modifiers. Like I mentioned earlier, we have introduced modifiers as a whole new primitive for interacting with the DOM. If you're not familiar, modifiers have 3 lifecycle hooks, and they get applied to an individual element. They get ran when the element is inserted into the DOM. They get ran whenever any of the values that are relevant to the modifier have updated, so any values you pass to it. And they get ran when the element is about to be removed from the DOM. And they're very one-to-one in that way with the old lifecycle hooks on components. We also released, as a way for people to update quickly and get used to the new system, this Ember render modifiers package, which includes 3 basic modifiers, one for did insert, one for did update, and one for will destroy. This is mainly because Glimmer components don't have any lifecycle hooks. They just have constructor and will destroy, which does not run before you remove the element. It runs when the class itself, the object itself, is going to be destroyed. So we've seen a lot of people jump in and immediately start rewriting everything in terms of just these modifiers, like treating them as the feature. They aren't. You can write your own modifiers, and that's definitely encouraged and even recommended to some extent. It's a little bit cut off there, but it says, having trouble replacing an observer. Consider using a modifier or helper. Modifiers and helpers can side effect, and there have been some cases where we actually think that makes total sense. Like when you're trying to communicate with an external library. I actually had a great discussion with Ben Dembowski on Discord about how he is working in an Electron app, and they need to be able to set the state of the app menu in the actual application, not in the browser. And that's not something that can be modeled by Ember directly. So you need something that communicates with the outside world. And in this way, helpers and modifiers are kind of like the use effect of our ecosystem. They're in a way to observe some changes and run some sort of side effect in code sometimes. So yeah. I also just wanted to give a quick note on two-way data binding because that has been coming up. And what is up with Mute? I made a pre-RFC, a series of pre-RFCs recently that y'all may have seen about various features that were going to be deprecated. They were more like intent to RFCs. So Mute was definitely the one that threw up the most confusion and concerns, and I definitely thought that there was a lot more consensus on what the future was here. So it was good that we got that out of the way. But yeah, I just wanted to clarify a bit what the story is there. So you can actually use two-way data binding throughout Glimmer components. You can do it through referencing named arguments directly. So for instance, you might use the input component and pass a named argument directly to its value, and that'll work, and that's great. This should help ease the transition path
into Octane. One thing we definitely all agree on at this point is that it's probably not a good idea to try to rely on the mute helper to modify values, though. It definitely wasn't its original intention, and there's still discussion around whether or not mute and the ideas behind mute will make sense in the future. I think there's a lot of promise there, and so definitely interested to see where that goes. But one thing we all seem to agree on is you shouldn't try to introduce two-way data binding to a Glimmer component only, like a Glimmer component that isn't using classic components at the moment. And really, arguments and actions are here to stay. They are a solid base to build upon. I definitely think we can talk more about and design more solutions for two-way data binding like ergonomics. And I actually have been working on an add-on that does just that. So definitely interested to see where that goes. But yeah, so moving on. The last section I wanted to talk about was some relevant libraries that might help you through this transition. The first one is control flow components. So you can't actually use positional parameters with angle brackets. That was a little bit of a lie earlier when I said that they are exactly the same as curly invocation. Curly invocation can receive positional arguments. And the idea here is that curly syntax really indicates that you're doing something more, more control flow-like in the DOM. So for instance, you see curlies in an Octane app and you think, oh, that's an each, that's an if, that's an else. It's showing you the logic of your templates. That's a helper or a function that's being called. And you might want to write your own control flow helpers or components. This is a component manager that allows you to do that, and I think it's excellent, a great idea. They built an async await, I think, on top of it, and it works really nicely. So another thing that you're going to have to do if you do want to start writing modifiers, you're actually going to have to install a modifier manager. There is a modifier manager API that's public, and you could write your own if you wanted to, but I highly recommend avoiding that and just using one of these. I think at this point we are pretty close to having a finalized modifier API, and I really see both of these existing ones as kind of like the helper and the class-based helper and the functional helper, essentially, of modifiers. Functional modifiers, made by Spencer, actually, there he is a very simple, straightforward modifier API, and it's great for your simple modifiers. But sometimes you do need to get a little bit more into the weeds and figure out what are the exact things I want to do when I update, when I destroy the modifier, etc. And that class-based modifier is definitely good for that. It's basically the same flow with helpers. Start with a functional helper. If you need a class-based helper, upgrade. And then recently, I released a library called Tracked Built-ins. And the goal is to provide tracked versions of all of JavaScript's built-in classes. So essentially, using these arrays, objects, maps, etc., if you use their standard public APIs, they should be fully tracked. Any mutation to them should be tracked and will cause the DOM to update, cause your components to update, et cetera, et cetera. There are some caveats if you care about compatibility or performance. As it turns out, you kind of have to use some expensive things in order to intercept any set on an object or an array. But we have a mode where you can run without native proxies, which are the expensive thing. And basically, that mode just minimizes the weird things that you need to learn. For instance, with tracked array, there's only two new methods that you have to use, get and set. You get the item at an index, you set the item at the index, but every other method works just like standard arrays and is tracked. No push object, no pop object, push and pop, that's it. it's good. Yeah. The other thing about that is because of the way that Ember works, you are actually able to access this tracked arrays using completely native syntax if you follow a few rules, which are all detailed in the README. But that way you can just actually use native syntax for most of the time, and the only time you can't is when you really need to set a very particular index. So it's kind of cool. And then I also wrote a library because a lot of people have been asking about how do we write macros? How do we do things like alias and or? And the thing is, like, that the whole CP system for doing that is actually quite a bit convoluted, and definitely not something you want to continue to rely on, in my opinion. But yeah, that kind of metaprogramming might still be valuable. So I wrote a pure TypeScript-based, not Ember at all, decorator library that does that for you. And you can import it using Ember auto import, and yeah. Generally, same kind of API or very similar. Yeah. And finally, just wanted to give you all a couple of resources. So we have the official edition guide. This will definitely be your #1 source for like how do I convert A to B. It's also under construction. We're working on it. I'm working on all kinds of things like the ability to add nested navigation in the guides and all kinds of stuff. The Ember Atlas. So the goal here is to capture like it's a bit of a wiki that I've been working on with a few other community members. And really the goal is to capture like as much information as possible. So like, especially the last time we went through these kinds of transitions, there would be a lot of questions like, how do I get rid of observers? How do I have like hundreds of them in my application, and they're all like, every situation is bespoke and weird and unusual, and I don't know what to do with that information. Like, I don't know what to do with it. Every time we find a new situation, we want to actually capture that and put it somewhere so that people can actually learn from people converting from computed properties to track properties, from classic components to Glimmer components. When you encounter your weird one-off solution, we want to find a way to store that so that future people can just visit it all in one spot. So this is a community-run thing, not a core team thing, just to be clear. But that's the goal. And also has like various other things in it. We have a like Ember for React devs kind of guide that we've been working on, and various other cookbook style things that we're basically trying to build out. And you can get that at emberatlas.com. And then on Discord, we have the topic Octane migration channel. Please feel free to jump in there, ask us questions. And me and Rob Jackson are planning on doing office hours every Thursday at 1 p.m. EST, 10 p.m. if you're on the West Coast for some reason. So yeah, that's it. Questions? Yes, so it does two things. One is it actually reopens the class. Like I said, it's going to try to enforce that you apply it. When you install the add-on, it actually reopens the class. And if you haven't decorated a class with the classic decorator, and you should have, it'll try to yell at you. It'll try to assert. It also provides a way for linters to actually do linting. Like, there are certain things that we can't assert on, but we can lint against. But we can only do that if we know which classes are supposed to be classic and which ones aren't. So. Oh.
That's weird.
Huh.
Well, I'll keep talking to the mic. Sure. In new template-only components, I've seen that this kind of ties into mute a little bit. You can't set values to names that are only defined in the template that aren't passed in, or I guess you couldn't do that anyway because you can't reset arguments. Can you talk a little bit about that now that there's no JavaScript backing the template, there's no like context onto which you can set values?
Right. So yes, that was a very intentional change. Basically, template-only components don't actually get a class instance. They don't get a this anymore. And like you said, that means there's nothing to set a value onto when you use mute, or if you were to use the input helper, for instance, with this, attempting to do that. Really, the goal is to make template-only components much more straightforward, much more like functional components in other frameworks. They are a pure output based on their input, based on their arguments, results of their arguments. And I think right now there's going to be a bit of friction with that. I think the value is actually going to be much more visible once we ship a template import syntax, because then you will be able to define helpers and modifiers either inline right above your template or in a file right next to it, not in the global namespace. And those will provide like direct analogs for things that you really have to do in components all the time, like derive some state. You need to have a computed property. Well, you can just define a helper. You need to have like a little bit of a modifier. Well, you can define that locally. So then template-only components will be much more powerful. And you'll only need a component class when you really need to have some local state. And that's it, yeah.
Cool. One other question for Chris? Well said. How many people here have tried Octane itself on a new app? How many people have tried upgrading their app to some of these features? Yeah. Okay, great. Thank you, Chris. Thanks so much. If everyone wants to take like 3 or 4 minutes, get up and stretch your legs, say hello to someone. It's going to set up, and then we'll jump right in.
Also, if you're looking for the restrooms, it's down the hallway. If you're going to use the women's restroom, there's key cards by the door.
Hello.
Turn on your mic. Is it that?
Testing, yep.
Yep.
This was
Okay, I'm good. If people want to filter back towards their seats, we're going to keep this break a little bit quick and jump in with Hassan, and then we'll give you a nice breather before Ed goes into our final talk of the evening. so how many people, we saw how many people have tried out Octane a moment ago, and it was actually a good number of people. How many people have a patent in their name?
I have 2.
All right, please welcome Hassan talking to us about Ember Concurrency with blockchain.
Hi, everyone. My name's Hassan. I work here at Cardstack. We're so excited to have you here today. And today I'm going to talk about Ember Concurrency, but for the blockchain. So mostly this talks about Ember Concurrency. So don't freak out. People like leaving for the door now.
Take my money.
So I love Ember Concurrency. I actually love it more than Ember. Sorry, Tom. Ember Concurrency is a really great abstraction on top of promises. If you haven't used it yet, please check it out. It is really fantastic. The documentation is excellent. It provides all sorts of interesting concepts and ways of reasoning about canceling async things, restarting, dropping, queuing, managing how concurrent things are in a really simple, easy-to-use manner. One of the coolest parts about Ember Concurrency is that it's built into the component lifecycles. I have a hypothesis that if you have an Ember component and you are awaiting inside it, or you have a promise and you're .venning inside it, you probably have a bug that you may or may not know about. And so if anyone has done anything like this before, they have probably seen a cannot call set or cannot call get on component that is destroyed. And so that's like one of the really frustrating parts about doing async inside of a component is that while your async thing is happening, your component may go away. And then when the promise resolves and you try to do more things after your promise resolves, there's no more context anymore. The component's gone. And so the great thing about Ember Concurrency is that it solves all of this for you using tasks. And tasks are canceled when components are destroyed. So check it out. Use it. If you do any kind of async inside of a component, definitely use it. So the thing is that life is complicated. Sometimes we have to deal with things like the blockchain. So I love this. I love this picture. This is many people try to explain the blockchain, but this picture is probably one of the best explanations I've ever seen. Notice the Mew slide of fun. It's great. It's super fantastic. Mew is My Ether wallet, and so this is they don't have. So My Ether wallet's a pretty famous wallet if you use Ethereum. And they've taken down this picture. It's horrible, because this is really actually quite fantastic. So I'm going to talk about the blockchain just really quickly, just to give you guys a little bit of context about the rest of the talk. So the idea is that, OK, so in the blockchain, I'm going to talk about Ethereum specifically. In Ethereum, we have these things called contracts. You can think of a contract just like a class. And an instance of these contracts lives at an address. Contracts are really just buckets of state that live on the blockchain. And so the idea is that you can have some kind of client that maybe lives in a web browser. And the idea is that these clients can send transactions to these contracts. The way they do it is they send it to these nodes. And in this case, My Ether wallet's a node. But the idea is that they take their little transaction. It slides down this slide of fun. And then it ends up in this thing called the pool. It is called the transaction pool. And so these different nodes there's a lot of different types. Well, there's 2 main types of nodes. One is called geth, one is called parity. That's not important. The idea is that there are nodes. And these nodes are the things that are actually the various peers that live on the blockchain, all like communicating. And the thing they're communicating is this little pool of transactions. And the idea is that there are these miners that live on the blockchain and they see these transactions. And there's like little dollar signs hanging off of them, actually. And that's called the gas. And so when you want to send transactions, you have to provide some gas. And the more gas you provide, the more lucrative it is for a miner to pick it up. And the miners, they pick up these transactions in their little buckets, and they slop them into the blockchain. And that is the blockchain. Woohoo! OK. So the thing is that if you want to have an application that lives, like a web application that actually can interact with the blockchain, there's no real simple promise that you can await. The idea is that, yeah, you send your transaction to your node, wherever it may be. You can have a promise around that. But then when does the miner pick up your transaction? When do they put it into the blockchain? When do you actually see it? When does your node actually receive that? I don't know. Maybe 30 seconds, maybe 10 hours. Who knows? So how, if you're trying to build an application that can like deal with the blockchain, how do you wait for things to happen on the blockchain? So this is where we have Ember Concurrency. So like I was saying before, there are some really fantastic abstractions on top of Ember Concurrency for helping you reason about asynchronous things. And so this particular strategy that we have taken actually allows you to deal with things that may take a long time, may take quickly, may never even happen. And so I want to real quickly just show you what this actually looks like, just so before we dive into the code. It's not horrible. And so the idea is that this is an application called Tally. This is one of the applications we recently built. And so just real quickly, Tally provides these prepaid cards, if you will, much like a Starbucks card, but for software. Or maybe coffee too, I don't know, it's up to you. So the idea is that you can take some cryptocurrency and convert it into these prepaid cards. And so as part of that, I need to send transactions to the blockchain to do this. Okay, so let's just actually see some of this, wacky, crazy stuff in action. So say, for instance, I want to buy a prepaid card. As part of that, I need to what's called stake a token. I need to take some cryptocurrency and then stake it into a smart contract. Basically, what this means is I have to call a bunch of smart contract things. And so I happen to have my Ether wallet or a cold wallet. It's like a regular wallet, but it's attached to my computer. And so what I'm going to do is I'm going to take one of these currencies here. These are popular currencies in the internets, and for this to work, I actually have to do two different things. First, I have to give my smart contract an allowance, and then I have to tell the smart contract, okay, I want to stake this token. So I'm just going to say I will take 5 of these DAI tokens, which happens to be worth this. This is a whole nother conversation that we can have at some point in time if you guys are really curious about what's actually happening here. It's quite fantastic.
So you're going to spend $5 on this talk?
Yeah. Well, no, actually, this is the test network. I'm going to spend $5 of Monopoly money on this talk. So, anyways, okay. So when I do this, ooh, what's that guy? So this is actually Metamask. Metamask is a very, very, very popular Chrome extension that allows you to send transactions, move ethers, what have you. I'm actually using this to actually send some of these DAI tokens here. And when you send it, you actually you can send it with a little bit of gas. This is your fee for paying the miners. The more you give them, the faster they'll mine this thing. That's actually pretty aggressive. This should be mined quite quickly. I am going to do that, and then so it's going to ask me on my little cold wallet here, hey, do you really want to actually do this? I'm like, yes, I do. No, I really do. Oh, I really, really do. Okay, so super awesome. So this is the thing right here. So look it, we're waiting. The transaction's going, it's sliding down the Mu of fun. It's miners like, oh, it's in the pool. Like, oh, look at this. It's got some gas there. I'm going to pick it up. I'm going to put it in the blockchain, and then I'm going to broadcast my blockchain out. And so how do we actually know when this thing gets done? But it did. It did get done. The promise resolved. So cool. So that was like a whole big pile. Okay, just to make this all completely done, there's actually 2 transactions you have to do. So I'm just going to do this one more time. There are other tokens that are more sophisticated that don't require you to do 2 things. This is an old-fashioned token, but I wanted to do this particular token because this is the example we're going to go through in just a moment here. But the same kind of story here. And then it actually did a thing. And actually showing you this thing. You could actually go to this particular address on Etherscan, take a look at all the cool transactions that I just issued. Okay, so what happened there in terms of how I was able to figure out when that transaction actually got mined? Because as I was telling you, there's a lot of stuff happening in the blockchain, and there is no single promise to actually listen to let me know that the thing actually got mined and I know about it now. So the strategy that we take here is that we have 2 different asynchronous tasks. This is what Ember Concurrency calls these things, tasks. And we're going to race them against each other. So the one task is polling. So I'm going to constantly poll my contract just to get the allowance. That was the example I showed. Just to get the allowance to see what it is. And after a certain amount of time, I'm just going to give up. There is another task, and its job is to actually just to see if the allowance that I have set actually appeared in the contract. That's its whole job. And then I'm going to race these two against each other. And as soon as either one of those completes the race, we're done. The task is complete. And then we can stop our busy indicator and then show the next thing. And so that's kind of what we're looking at. The first thing, send it, then we do the race. So let's take a look at the actual code for this. And so I pulled, this is real, but I pulled out all the parts of it that are not germane to this conversation. There's a lot there. Anyway, so let's piece this apart a little bit. So the first thing here, this is the actual action that we're kicking off from our template when we push the button, the approve allowance. And so the idea here is that we're just sending this transaction. Web3 happens to be a very popular JavaScript library for Ethereum. We're just sending this transaction. We're calling our contract. And we're invoking the approve function on the contract with the actual staking contracts address and the amount that we want to actually approve. In my case before, it was 5 of these DAI tokens. And then so we do that thing, and then we wait. We wait for it to be approved. And this is the magic here. OK, so the race. Here we have the race. And look, it's super simple. This is a great part about using Ember Concurrency. Like I was saying, the abstractions are really easy to put together, mix and match like Lego blocks. So we have a race, and then we're literally just racing these 2 other tasks right here. And whichever one finishes first is going to be, that's when we actually complete this overall task here. OK, so let's look at the poll. So in the poll, we have it right here. And so the idea is in the poll, we have this wonderful timeout function that Ember Concurrency gives. And it just basically means exactly what it sounds like. It just waits. So the idea is that we have a for loop. We keep going until some maximum amount of time. And that after that maximum amount of time, we give up. And we're just like, I don't know. You figure it out. So within this poll, then, we wait. And then after we wait, we then get the current state of the contract. And so you can see it right down here. And this is real simple. It's just saying, hey, contract, what's the allowance? And then we figure out what the allowance is, and we just put it into a property that's hanging off of this component. This is all inside of a component. We just put it inside this component. So the next part, it's literally one of my favorite parts of Ember Concurrency, one of my favorite functions. This is literal magic. And so the idea here is it will just wait until this particular property on this component is equal to that amount. And as soon as that happens, it will resolve. There's another one here, like there's wait for property. There's like wait for event, which will just wait for a DOM event. And I think there's a third one. I can't remember it. But this is pure magic. And so the idea is that that poll set allowance, it's just going to keep setting the contract allowance every so often. As soon as it hits the thing where we think or we want, you can even be more generic here, like just check to see if it's different. Whatever you want, you're just waiting for this thing. And as soon as this is set to the amount of the contract appears, it will be done. That's it. That's the thing. So I loved it. And because of Chris's wonderful talk about Octane, let's talk a little bit about what it means to do Ember Concurrency in Octane. And so it's actually really simple. The idea is you can just take this decorator and just wrap your entire task in it. And so it just, boom, now you have Ember Concurrency, and then you'll notice at the very end, you still do have to name it right here. But yeah, it's literally just wrap the whole thing in a decorator, and that will give you something that's compatible with Octane. So awesome, awesome. So when I was first doing this, I ran into this error here, and this error, it's like, oh, okay, it's an error. And I read through it a little more deeply, and it kind of blew my mind on what this actually meant. And it blew my mind so much enough, I really wanted to talk about it because it was kind of cool. So when I first did this, I had an action that was, it wasn't the task we were looking at, it was a different task. But I had an action that would invoke or perform some task, and then I just want to set some state on the component after the task is done. So I just like, oh, I can await it, right? No big deal. So I awaited my task, and then this dot set whatever, blah blah blah, and then I got this task cancellation. What the F is this? So I went through the documentation. It was apparently this has happened enough that Machi actually put together an FAQ for it, and basically what happens is anytime you await or .then a task, you will see this thing. And what it means is that Ember Concurrency sees that you're trying to do, it sees that you want to wait for this thing, but it's like, I have a task, man. It has all these superpowers, but because you've awaited it or .then'd it, I'm just going to give you a plain old boring promise, and then you can deal with it. But now we have a plain promise. What happens if our component's destroyed? Now we're like back to step one, and the whole reason why we're using Ember Concurrency in the first place. So the thing is that don't await or .then your tasks. It's going to turn them into normal promises, and that is not at all helpful for you. I like to think of it as like green kryptonite for Ember Concurrency. It takes all the power of it, just drains it. So just don't do it. Instead, take that. In my example, I had an action. Wrap your task inside of another task. That is totally cool. You can do that. And so you can just create another task that just yields the task you were going to yield and then sets the thing you were going to set. And moreover, instead of having an action to call, you can invoke that thing directly from the template using a perform helper. So just do that. And so yeah, if you see this, it means that you have awaited your task. Don't do that. OK, and that's it. Woo! Yes.
Would returning a task performed from a model hook incur those task cancellation errors?
That's a good question. I think that in that case, you would not. The task could still be canceled, but for perhaps other reasons, not because of component lifecycle reasons, but for other reasons. So in that particular case, you need to assume or you need to understand that that particular task cannot be canceled because it is been converted into a regular old promise. You cannot cancel a promise. But I think that in that scenario, now you have like all the asynchronicity that goes along with routing that allows you to handle that sort of situation. But yeah, that's a great question. I don't know about that. I think you're probably fine, but you're not going to have when I was originally stating the sorts of problems you can have, I was mostly focused on components specifically. But within a route, I think you're fine because it's already built to handle asynchronicity.
I think you get the error template if you test cancellation.
That's true. That's true. Yeah, that's a good point.
Yeah, hi, Tom from the Professional Social Network. How does Web 3 compare to Web 2.0?
Web 3 is so much better.
Nice. But I didn't need to spend gas on Web 2.0.
But now you're like a crypto billionaire with a Lambo.
Fair enough.
So.
All right, excellent. Thank you, Hassan.
Woo! I love blockchain.
So now that we have learned how to write our Ember code and we've seen cool things that we can do with our Ember code, take a breather and let's learn how we can compile our Ember code. don't even need to be here. Ed can just like jump into things.
You're well respected.
This is perfect. It doesn't work like this at home. Not nearly the same. Just waiting for Sam to sit down. He's got to get him some rum. All right, so Ed Faulkner is going to close us out tonight. Ed is an Ember.js core team member, but he got bored, so we decided that he would re-architect Ember CLI. He's giving us a talk tonight that he's given a little bit of an Ember camp, and I think he'll give a little bit more of an Ember fest, so where the meat and the sandwich, all the good stuff is going to be right here.
Yes.
And yeah, welcome Ed.
Thank you. All right, so this talk, am I really loud? Okay, perfect. Okay. This talk starts out really trying to get people to not be afraid of the word compiler, get a little comfortable with the concepts, and then moves into what specifically, how we're relating that to Ember. I'm going to try to take it fast so that there's more time for some interactive Q&A. So that's your bonus content on top of what I already did at Ember Camp. So compilers do have a little bit of a scary reputation. If you took computer science in a university, the compiler course is a scary course sometimes. If you didn't take computer science in university and you got directly into web development, you probably didn't have to think about compilers at all. So it might just be a total blank. The point of this talk is not to arm you to go out and write a compiler from scratch. That is a big job, but it's to help you understand the terms, understand the concepts, know what they can and can't do, and that's really empowering. It shows you, kind of helps you think about problems and where reaching for a compiler is the right solution. And thinking about beyond compilers, the same kind of things you have to think about in designing a compiler, which designs a computer language. A lot of the same skills go into designing any API. We're all designing language. Whenever you make a new function and you give it a name, you're really extending the language. And so a lot of these same lessons come out. So it applies to everybody. So what is a compiler? The word was coined by Grace Hopper around 1950. And by 1952, she'd written the first one. And she had to work really hard to convince people it was a good idea. People didn't believe you could do computing this way because at the time, everything was so constrained and so low level that the idea of letting a computer assemble your programs for you from some lofty, high-level language that people would understand was a pipe dream. But she did it. And this is a diagram out of a paper she wrote in 1952. And this is the level of detail she had to go into to try to explain to people what a compiler is for. And so there's your brain goes here. Right? You do this part, the computer does that part. And so she was really trying to explain a new division of labor between the programmer and the computer. And we take that all for granted now, but she was inventing it from scratch. And she had to come up with all these kinds of concepts that we know. Right? She called them somewhat different things, but we can recognize these ideas. So what is a compiler? A compiler is a program. And of course, what is a program? Let's back up a little and get really abstract here. A program is just a set of instructions that takes some input and gives you some output, right? That's a really general purpose way to think about programs, but it's important. And we usually don't think about our Ember apps that way. When you think about an Ember app, what's the input and output? Your input starts as a URL, and then it's a bunch of events from users, and your output is HTML, right? So it absolutely fits the model, right? So a compiler is a program in the same way. So a compiler, though, its input and output are other programs. And this is where the reputation for them being scary comes in, because it starts to get recursive right away, right? Now, of course, writing a compiler whose input is only one very particular program wouldn't be very useful. So when we really say the input is a program, we mean the input is a program in some language, right? And the output program, of course, should probably be in some consistent language, too. So there's an input language and an output language that our compiler supports. And there's one language missing from this slide because the compiler is written in some language, too. So there's actually a third thing here, right? And I highlight these three languages just to kind of give you some of the terms that people use about compilers. Some people get really specific and would say that a true compiler is really one where the input language is easy for humans and the output language is easier for machines. And some people think that's a compiler. I think the broader term that I'm using is the one I prefer, and it covers a lot of broader cases, but this is like the classic idea of a compiler. The opposite of that would be a decompiler, where it takes something that's easier for machines and converts it to something easier for humans. This would be like a reverse engineering tool. A self-hosting compiler is one where the input language and the language that the compiler is written in are nearly the same, right? And this is the idea that it's a compiler that can compile itself, also called a bootstrapping compiler. Babel's a bootstrapping compiler because it's actually written in JavaScript and compiles JavaScript, right? And most languages evolve to be bootstrapping. Most compilers that try to get really serious try to become bootstrapping compilers, to be written in themselves, which actually causes a kind of a neat kind of hereditary aspect of compilers, because once they get to that point, like they'll compile themselves after that, but the very first one had to get compiled to some other compiler, right? And that chain goes back really far. I mean, it goes back to like very early. Somebody had to hand assemble stuff, right? But ever since then, there's a chain of compiler heredity, and it's just kind of an accident of history. You can't see you can't look at a compiler and know that it was compiled by whatever, but the effects are there, which is kind of cool and mind-bending. And finally, when the input language and output language are nearly the same, we might call it a transpiler. And all of these terms are, I highlight them so that you know the terms and you could speak to them and not be confused about the differences. But at the high level, they're not very interesting. All these are compilers in the way I'm defining them. And the fine distinctions aren't super important. Is Babel a transpiler or a compiler comes down to the question of whether like ES 2019 is the same language as ES 3. Like, if you think they're the same language, then it's a transpiler. If you think they're really different languages, then it's a compiler. Doesn't really matter, though. So what can compilers do and not do? And this is actually still getting into what they are, because one way to know what you're looking at is, can it do the things compilers do, then it's a compiler. So we said compilers are a program whose input is a program and output is a program. We also said every program has an input and an output. So we can think about things like this. We could think about the output program having inputs and producing outputs. And if you look at the flow of where the data goes in this diagram, you can see that the compiler doesn't really know what the input is, right? The compiler can't know what inputs are going to be given to the output program. In fact, the output program could run many times with many different outputs, and it's supposed to work on all of them. So the point of this is the compiler doesn't know the program input, and so it can't run the program, right? So compiling is not evaluating. Compiling is not running. It's a different thing. And it means the compiler can only know certain things about the program, and it can't know everything. And the terms we use for that is static versus dynamic. So static describes things that you can know about the program before you run it. Dynamic describes things you can't know until after you run it. Now, static and dynamic are very useful words. They get reused in programming for different things. So they don't always mean exactly this in different contexts. I'm going to try to use them to mean only this in this talk. And I'm going to slip up, actually, because it's very hard to use them that precisely. Because they're such useful words, and we do slip them in for other things. So getting back to our diagram here of the input and output for language B, of course, we said every program has an input and an output. So we can also think about the input program having input and output. And this brings us to one of the important things that compilers do, because they're supposed to take a program written in language A and turn it into a program written in language B that means the same thing. We'd say it has the same semantics. So for the same input, they should get the same output, right? So the compiler doesn't change the meaning, it just converts to a new language. And this is a really important concept because it requires us to get in the habit of thinking abstractly about something that isn't always right in front of our noses. Because this arrow down here, going from program A to the output, is often unimplemented, right? A lot of things need to be compiled before you can do anything with them, right? So if you have a classic program written in C, you can't just take that C program and get an output. You have to compile it first to a binary, and then you can run that, and then you can get an output, right? So that's why I say going directly from the program to its output is unimplemented. That same idea is true for your Ember app. Your Ember app has files like app.router.js, app templates application HPS. Those aren't things a web browser knows how to run. It's not runnable. You have to run it through our compiler first, Ember CLI, to get the assets that go in a directory called dist traditionally. And those the web browser can run to give you an output, right? So going directly from the code you authored to the output is unimplemented directly. But the point of what I'm bringing up is that just because it's unimplemented doesn't mean it's not important. And it's actually a very powerful way to think about programs, to care about what the semantics of the program are, independent of the implementation and independent of the compiler. Because if we only think about what really happens in terms of the data flow, we have this long chain of events going from before you can take if you have an input and you want to get an output, first you have to take the Ember app, compile it, use the semantics of the output program to give you the final output. And it means if you're trying to think about and understand what the code in that app means, you're thinking about what the compiler will do with it, and then you're thinking about what the web browser is going to do to run that. And it means you're not really thinking in the language, the input language. You're thinking in too much of the implementation detail. Contrast that with thinking about it this way, where you just know what an Ember app means. When you see a certain code in there, you know that it corresponds to a certain output. That's a much more pleasant way to function. The ideal is that you're able to think in your language. You don't have to go down to another level, right? And so forgetting to do this, I'm just going to label that mistake here. I'm going to call it the implementer's trap, where you neglect the abstract semantics because you know how it really works. And so you get too into the weeds, and you forget about taking care of what is the abstract semantics of this language here, what's it supposed to mean, independent of its implementation, right? And I'm calling it the implementer's trap because it's the people who implement this stuff who are the most at risk of falling into the trap because they know how it works. And that extra knowledge can be dangerous. And this is one of the things that applies not just to compilers and not just to languages, but to really any API you design, right? If you know too much about how it works inside, it actually can hamper your ability to design a good API that makes sense from the outside. So does Ember succeed in not falling into the implementer's trap? Do we have clear abstract semantics? Overwhelmingly, yes. We have really good abstract semantics, and there's a couple of reasons for that. One is that we adhere really closely to web standards and web specs for how JavaScript works, for how HTML works. And those things are very deliberately designed to be abstract semantics, right? When the spec for how JavaScript is supposed to work, it doesn't tell you literally what lines of code are going to run in V8. It tells you what it's supposed to mean in the context of JavaScript. And so if you follow that spec, you are respecting the abstract semantics. You're not tied to one implementation. You're not tied to what V8 will do or what Node will do or what Safari will do. It's just JavaScript on its own merits. So we do that, and we do that for HTML as well. The other reason that we have good clear abstract semantics is that Ember's own APIs are designed pretty carefully to do that. Right? We try to be very declarative. We try to define what things do and not necessarily how they do it. And over time, we've even gotten stronger at that. An example from what Chris was describing about, say, async observers, right, is it's another example of where you can describe what you want and not worry about exactly how it happens. Synchronous observers, actually, you're tied more tightly to the implementation than you would with an async one, where you don't know when it's going to run, but you don't care. Right? It's more abstract. You're less tied to the implementation. So overall, Ember does this great. But we have an area where we need improvement, and that is modules. So Ember was a very early adopter of module syntax in JavaScript, which it turns out to be very good for us because it means almost all of our apps are written in it. And that's very powerful because it's a very good syntax that turns out to help us in what I'm going to show next. And people involved in writing Ember also helped write the standard for modules. We were there basically testing it out and getting it good. So we've been using them as a syntax for a very long time, but we haven't fully adopted their semantics. And there's both some things where we violate the letter of the spec and some where we kind of violate the spirit. So to give an example, if you had these two files in an Ember app, well, I guess the question for the audience is, what should this do? We export a named function called greeting. We import our utilities that it's in, and we try to run it that way. Yes, it's supposed to error, right? It's supposed to error because, like utils here, the module, it doesn't have a, like you have to actually do either this with a named import or this to get the actual whole module. Both, either of those would work, but the first one doesn't. It's not supposed to in JavaScript. But what does it do in Ember CLI? It works.
Really? Really?
Yeah. Yeah. And it wasn't entirely a mistake. It was compatibility for earlier days before modules, but it's still there. And so it trips things up. And so when I began statically analyzing a large number of add-ons across the ecosystem, you find things like this.
As one does.
Yeah, well, yeah, as one does. We're getting to that, right? So this particular bug is like not a big deal. It comes up in real. I'm sure it comes up in real apps because it comes up in real add-ons. But you can find it. You can turn it into a static error and like make it go away. Not too big a deal. So this is an example of us like not following the letter of the spec. But the rest of what I want to talk about is a slightly harder problem, and I'm going to say it's more about violating the spirit of the spec. And to do that first, I'm going to talk a little bit about the spec, how modules are defined, and what they're supposed to do. So this is a bunch of import statements that you would have probably seen in an Ember app, right? Like maybe not Glimmer component yet if you haven't adopted Octane, but you've seen these kind of imports in an Ember app. All right. What do all these things mean? Right? Even if you know how it works in the implementation, what do they mean? Can you say how they work independent of the implementation? Right? And the answer is basically no, because it's extremely implementation defined what each of these does. And in fact, all 4 of these do something different in terms of what the module specifier means. The module specifier, that's the language in the actual JavaScript language spec for that part that I've highlighted in green. The string in an import is called the module specifier. And what it means in each of these examples is actually quite different, where they come from and how they work inside. Now, like, they have the right flavor. Like, they do give you what you ask for. If you ask for queuing, you get queuing it. But how you get it, what file on disk that means, where it comes from, is very implementation defined. Now, the good news is this doesn't actually violate the letter of the spec because the spec doesn't care. The spec deliberately leaves the meaning of module specifiers up to the host environment that the JavaScript is running in. Meaning, in a web browser, it's up to what the web platform thinks module specifiers are supposed to mean. In Node, it's whatever Node thinks they're supposed to mean. So JavaScript doesn't care what they mean. However, let's look at a few other features of modules to see what the overall overarching theme of imports and module syntax is. So this is an example of something that's not valid JavaScript syntax. Right? You can't import from a dynamic string like that. Right? Why isn't this allowed? Anybody? Yeah, you can't statically analyze it, and that's the use of static that goes with my earlier slide, right? You can't tell without, in general, you might not be able to tell what this means without running the program, which means you might not be able to tell what this means without having the inputs, which means a compiler couldn't tell, right? You might not be able to tell till runtime what that means. How about this? This is also not valid JavaScript. Why? Same thing, right? In general, like if feature enable there could just be a function that you have to call that calls arbitrary code and talks to the network and who knows, right? So it's not statically analyzable. How about this example? So if you run this app.js file that imports the say hi file, what print will we get? What printf will we get? Yeah, hi comes first. Yes, I see some surprise in the audience, right? This is the syntax of modules, though, and this is what the spec says. It says it for a pretty good reason. It's the same. It's very much related to the reasons we just talked about. And Sam was inspiring good conversation on Twitter about this just this week. But it comes down to analyzability of being able to know exactly what order things would need to run in before you actually run them, right? If we allowed the console log before to run before the import say hi, it means now that like knowing when exactly say hi is going to run depends on arbitrary code that could throw, code that you might never get to. And another thing about modules is they're supposed to be idempotent. Like the first time you import, like they're supposed to only run once. And so if import say hi is scattered in multiple places in arbitrary code, when does it run? Can't tell. Can't tell till you actually run the program. So the theme here is everything about import is designed to be static.
Can you just go back to that?
Sure.
I think in this example, if this is the entire program, you can tell when it will run. Like, you could imagine saying before should come first, import say hi comes second. Like if you do like Node app.js, right? If you run the program app.js, everyone
Sure.
looking at this
Yeah.
can see
No, that's
it
true.
gets interesting
To make it more interesting, you
if
need
there was
cycles.
another module.
You need to make it interesting. You need cycles and more modules.
Yeah,
Yes.
yeah.
And but as soon as you
That-
allow
that
this,
was what made it click for me. That was
that's a good point. And maybe a more rich example. I mean, I think this example is good to show what the actual semantics are, because I think some folks are surprised by them. But yes, to
motivate why.
to motivate why
JavaScript
it's
decided
to motivate why
imports.
you'd want to look at the fact that if once you have cycles of inclusion and once you have multiple things including, it becomes very hard to analyze when things are needed, or even if they're needed. So everything about it is designed to be static, and that's why I say we violate the spirit of the spec, because our meaning is not static at all. It's dynamic in the sense that you can't know it till runtime, and even it's dynamic in actually two senses, and this is where I get into where I said like the meaning of the word dynamic is slippery. It's dynamic both in the sense that I said before, meaning you have to run the program to know what it means. But even at compile time, there's also dynamic stuff going on. There's compile time code that you need. Both of those things are a barrier to understanding things statically. And they're both a barrier to letting compilers really understand things really well. So as an aside, for dynamic thing, there's dynamic import, which is import with parentheses, which is a newer JavaScript feature that you can use in your Ember apps if you use Ember Auto Import or Embroider, as we're going to get to. And all of the things that I showed that are previously that don't work with regular import work with dynamic import. It can be inside conditionals. It can have a dynamic string. And the order is the order it looks like. All of those are true for dynamic import because it exists for that reason. So that's the end of this problem statement. Move on to the solution statement.
Quick question.
Yep.
That means that if you had dynamic import for the same module in two places, it would run twice?
It still runs once, but you don't necessarily know when it's going to run. And then it's accepted with the dynamic one that like you run it when you run it. It's much more like what require does in Node, which also is idempotent. You will, like the first time you require something, it'll run, and the next time it won't.
It'll just return it from cache or something?
Yeah.
Exactly.
Yeah. So I said part of the problem is that we don't really have a clear abstract semantics. We don't have a spec we follow for what these things mean. So the first part of the solution is to write a spec. And the first part of that solution is this RFC that is currently open. And it's titled V2 Add-on Format Embroider Compatibility. A note about why it says add-on and why add-ons are important. It's really about establishing a new format for how any Ember package is formatted, meaning add-ons and apps. But add-ons are the harder case because they're diverse, they come from many different authors, and they require a lot of coordination across organizational boundaries. So having really clear standards there is the harder problem, technically and socially. Like apps matter too, and all the things that apply about this apply about apps, but apps are the easier case. And so as a priority for what RFCs we need to land, it's actually getting add-ons into these newer formats first. That is the more pressing matter. So this spec does a lot of things. It's a pretty long RFC, which is why I think I've gotten very few comments. It's a great strategy for getting our RFCs through, by the way. If you make a really short RFC, everybody's going to read it, understand it, and have opinions. No, I think only Jen was brave enough to give me feedback, and it was it was mostly about how to teach. Oh,
That's your RFC.
I forgot about that. Chris printed it for me.
Are you serious?
Yeah. Yes. So, as long as you're cool with that, we'll merge the RFC. And the funny thing is I scoped it down, and I didn't put in all the features I wanted. But, and it's verbose because it's trying to do something kind of like ECMA does, right? We're trying to make a spec for the language, the input language that is Ember apps, right? Just trying to make it really precise and clear. And so there's hopefully nothing too earth-shattering in there, but the main thing that it solves that comes out of the problem statement I said is now module specifiers have clear semantics. They have one meaning. And they basically adopt the meaning of whatever it means to Node, it means to Ember 2. Which is basically the de facto standard that has the most weight behind it across the wider JavaScript community. And it also means we're like not tied to the particular implementation right now. To the extent that Node is going to support Yarn plug and play or other modular resolution strategies, we support that too. It's just like do what it does. And there's much more to it because, you know, there's details to get right, and I'm not going to go into the full thing right now. I'm happy to discuss any parts of it with folks. An area I'll point out as interesting that matters a great deal in the practical world of getting code upgraded to this is it includes a macro system, which is going to be a standard declarative way to get build time changes to your code that today you'd have to do with running arbitrary code in the build, in your add-on, inside of like writing custom broccoli code, basically. And by going to a more declarative inline in your code macro system, we eliminate one of those other sources of dynamism. Like now, add-ons can't run arbitrary code at arbitrary times to even decide what their source code is. Right? Like that's a source of dynamism that is very hard today. You can't. The actual API for what an Ember add-on can do, it's not like if you have a file under /addon.index.js, it means something. That doesn't mean anything. The only actual API for add-ons is the add-on's a program. You run it and it barfs out source code, and that's what the add-on is, right? So until it does that, you can't know. And so compilers can't know until they start compiling what's in there. And like your editor can't know, TypeScript can't know, your linter can't know. And so that's why a lot of things don't work that you want to work. So this solves those classic problems. The next piece of the solution is, so once you have a spec, great, but none of your code follows the spec. How does that solve your problem? That's where the actual implementation of Embroider comes in. So Embroider is a multi-stage compiler for Ember apps. And I'll talk first about what is a multi-stage compiler and why is it a good idea.
Can I ask a quick question?
Yeah.
To clarify before we move on to the multi-stage
Yeah.
compiler. Is like the biggest issue with the V2, the add-on spec? So is it like what the string resolves to? Is that if you need to put it in words like percentage breakdown, like that meaning what it means in Node is important?
Yeah.
And the non-dynamism part
Yes.
is
So
important.
yes, the important pieces are that what I said of making the module specifiers mean one thing reliably. In order to do that, there's a bunch of fallout. And so like you take away people's power to do, like it's basically taking
Like
power
shimming
away.
and stuff like that?
Correct. It's taking away power to do things like shimming and things like that. And so it has to answer the question of, well, what do you do instead? And the macro system is part of that, and there's more in there. And it also tries to answer the question of how do you, like there's things add-ons do today that, like how would I ever upgrade if I can't do all the things I do today? So it tries to give good backward compatible solutions for some of the things that you want and may always want, maybe eventually want to deprecate. We can decide those separately. For example, today if you just add an add-on, right, it pushes things into your app by default. You don't have to use the add-on to get code into your app. That is both good and bad. It's a double-edged sword. Sometimes it's bad that when you add an add-on, every component it has gets pushed into your app, right? We'd rather just get the ones you use. However, some things exist to do that. Like you want to just get them added. You want to add them and you get them. And so there's a place for that kind of a feature. The spec calls that implicit modules, right? Like some things should just get implicitly in. In the new format, you can still do that. You just have to list explicitly in package JSON in your Ember add-on section which things are implicit modules, right? Like so it still becomes more static. It's still a bit of like Ember-specific magic to how the build gets put together, but it's not nearly as dynamic anymore. And it's a smoother upgrade path. So multi-stage compiler. The idea is like it sounds. It's basically breaking up your job into multiple stages where instead of going all the way from your target language, your input language to your target language, you stop at intermediate languages along the way. And that might sound more complex than just going all the way from point A to point D, but it turns out it's very powerful and it's very popular. I'll give an example, which is that the Rust compiler has these many stages. This part won't be on the test, but it takes an input language that you'd write, which is Rust, and it goes to the high-level intermediate representation, which basically takes out a lot of the human niceties of the language just to smooth it out so it's easier for machines to deal with. Then it goes to the medium-level intermediate representation, which really breaks down a lot of the high-level abstractions into low-level abstractions, which then enables more optimization and more analysis. And then we get through all the way to LLVM IR. So that's LLVM is a separate project called Low-Level Virtual Machine. And the LLVM IR is the LLVM Intermediate Representation. So it's a language standard that is used by many, many compilers, including C, C++, Ada, Haskell, and Rust, and many others. And the reason you do this is because now your job of writing a Rust compiler ended there. Because now you could take LLVM IR and run it through the standard LLVM tool and get any of the many supported binary formats that LLVM already supports. And I point this out because this is a general pattern that's powerful about multi-stage compilers, and we use the same concept in Embroider. Right. There's really two benefits here that I'm trying to highlight. One is that later stages can do much more powerful analysis if the earlier stages have sanded off the rough edges. And the second thing is that you don't have to go all the way to your target language. You just have to go to a common standard where there's good tools to take you the rest of the way. So in Embroider, we do the same kind of thing. Embroider is a 3-stage compiler. We take your Ember app and add-ons, and first we run them through the compatibility stage implemented in the Embroider compat package. Its goal is to turn all of that input into a collection of v2 formatted Ember packages. Right, so it's going to absorb all the dynamism by running the dynamic bits and turning them into just dead code on disk, so that later stages have a much easier time finding things, right? Because by the time you get to the standard v2 Ember packages, every import really has one specific meaning now, right? That sets up the second stage implemented in Embroider Core to do the kind of analysis and traversal that wasn't easy or possible to do before, because all the dynamism that we've already squashed in stage 1. So the 2 stages really support each other that way. So for example, the core package can do things like resolve every helper and component that's referred to in a template, because there's only static places they can come from now. All the dynamic stuff's been fleshed out by the first stage. And so core then emits plain JavaScript, CSS, and HTML, all which just follow web standards and are basically in a form where approximately they could already be run by a web browser. Now, like that would be like a very capable web browser, and nothing's optimized. All the files would still be loose modules, right? But like in principle, it all follows web standards. And then that goes to a standard tool that knows how to optimize web applications. And so in our case, we have a 3rd stage called Embroider Webpack that uses Webpack inside to do that optimization, right? Webpack is like our LLVM. All we did was we didn't have to go all the way to browser optimized output. We went to a standard, and then we can adopt broader tools to take us the rest of the way. Yes?
Today, we go all the way to browser optimized CSS.
Today, Ember CLI goes all the way.
Yeah, all the way.
Yeah, today Ember CLI does all the jobs, yes. Today Ember CLI does all the jobs, and it doesn't have very clear boundaries of phases. I mean, it has phasing, but where the boundaries are is fuzzier and harder to work with. So part of the goal here is by having clear standards at each layer, it makes it easier to work with one layer at a time, and it makes it easier to experiment with swapping out layers. You know, not as a thing we want every app to do, but as a thing we want contributors to do, right? In particular, like the last stage here, the input is really very deliberately only web standards. It's not allowed to even be anything Webpack specific. So we're trying very hard not to be tied to one in particular implementation of the 3rd stage. A future tool that's not even written yet might be the 3rd stage we ultimately go to next, right? I would love to see like a pure Rust 3rd stage that's super fast, right? Or we might go with a very, we might just go with a use the platform 3rd stage when browsers are so good and HTTP 3 is so fast, we don't need to optimize anything, right? Someday, maybe. So I'll talk a little bit about what the stages do in terms of examples of the things they do. In the compat stage, custom broccoli transformations run. Files get moved around so that their import paths actually match where they live on disk. We recapture modules that try to escape their package. There's at least 5 ways that modules try to escape their packages in Ember add-ons, and I keep finding more. What I mean by that is like you npm install some name, and it provides you things that live in some other name. And that is sometimes a clever attempt at convenience, but it's just ultimately confusing to both you and the compiler and the linter and anybody who's trying to understand where the heck does this file come from. Like every default, if you just run Ember new, you'll be able to import from QUnit, but you don't depend on QUnit, right? That's the kind of recapture I'm talking about. So we're able to do that kind of thing because we detect in the build that things are trying to escape we can move those files back into the package from whence they came, and we have a rewriting system that basically lets, one of the compatibility things that v2 packages can do is they can actually declare aliases, a static list of aliases for, if you see this import, it really means that, which allows us to implement that in Babel and then like make it all line up again. We apply any custom pre-processing to each package. This means that today every add-on can bring its own custom Babel plugins, its own custom template transformations, can use its own custom template language if it wants to use its own, if it's written in Emblem or some other template language. That's all totally allowed. We want to get all that customization out of the way before we go to the v2 packages. Same goes, so on the JavaScript side, any custom Babel transforms have to get, anything custom beyond just the standard Babel things needs to get run, and take out the weird language features that are not supported by stable JavaScript, and just leave the things that are supported by stable JavaScript. That gets us down to a standard language. So v2 packages explicitly say it can only have this kind of JavaScript, not just bring your own transpiler that will emit eventually valid JavaScript or valid templates. And lastly, we generate some synthesized packages like the synthesized vendor package that end up wrapping up a lot of the classic behaviors inside of a valid v2 package. And the reason we do that is there's a lot of behaviors in classic Ember CLI that deliberately allow packages to smash each other's files and stuff like that. And to get that behavior compatibly, you need to put them into an actual package where they're allowed to fight it out.
So many amazing visuals. I wanted Hassan illustrations.
I know. We need Hassan illustrations for all this. And then they slide down the Mu slide. So in core, the core package the cool thing about the core package is it gets to live in the future, right? It's authored so that all of its inputs are nicely formatted v2 packages. So you get to author it the way you'd want to have authored it. And even though that today's apps aren't authored as v2 packages, stage 1 already took care of that, right? So that makes core a lot simpler, cleaner, and more powerful. And it lets you do, so it does things like synthesize JavaScript entry points, right, that are going to be like the main JavaScript files that a browser could run to start your app. And so when it does that, it's going to like write a bunch of import statements for the things that we know you need to boot an Ember app, right? Any of those implicit modules I mentioned, if add-ons are going to say like, hey, if I'm used, please make sure this file is included, we're going to have literally an import statement there, right, in that entry point we synthesized. That's how we're going to tell a later stage like Webpack that you need that file. We don't teach that later stage about add-ons. We don't teach it about engines. We don't teach it about routes. All it knows is JavaScript, so we're going to say in JavaScript what we need. And so things like routes and services and stuff, there's imports for them all. And where there are potentially, and we're going to, as I mentioned before, we're going to resolve components and helpers, and we're actually going to emit import statements for those at the top of each compiled template module. So the dependency graph covers our templates too, so that if the first time somebody needs a component that uses a helper is the first time that helper will get pulled in. And we can use the dynamic import to express potential split points like routes and lazy engines. All of that is taking concepts, Ember concepts like route, lazy engine, and turning them into just JavaScript concepts that are now expressible in standard JavaScript language. And then the final stage is optimized packaging, and you don't have to say that much about it, and that's actually really good, right? We just take a bunch of JavaScript that follows HTML, and HTML is the entry point, like it's not a JavaScript entry point, because we actually need the full expressiveness of HTML. But like, given some HTML, we can say following the spec what would a browser do with it, and we give the optimizer total freedom to decide how you deliver that to a web browser. So we don't say there's going to be an app.js file and a vendor.js file. Like, we don't care. We actually deliberately abstract that away from the app author and say, optimizer, do what you think is best in terms of what to name the output files, how to split them up, how many there should be. Because those are really optimization problems without there's not always one winning answer. There's knobs you might want to turn, and there's clever optimization strategies people could try. And having free to turn those knobs is great. So the benefits of this whole architecture are that now your builds are completely pull-based, meaning nothing gets in unless something actually needs it and asks for it. People usually express this feature as saying they want tree shaking, but I still think that's the wrong name for the feature. Tree shaking still assumes that you're going to like jam all the stuff in and then shake out the parts you didn't need. And this is really about don't jam it in the first place. Like, only get the things you need. Files can only get into the build if somebody expressed an import somewhere through this compilation process that they needed it. This does give you faster builds. Even, like, I'm not sharing benchmarks because it's moving fast enough that benchmarks that are true today aren't true next week, and apps definitely differ. But even with the full compatibility layer, it is on par with existing Ember CLI and sometimes quite a bit faster. As we get more add-ons, once we merge the RFC, add-on authors don't run out and ship V2 add-ons yet. We need to merge the RFC. Once we do, though, add-ons that ship natively as V2 need a lot less work, because in stage 1, there's basically nothing to do for them. And a full collection of V2 packages is blazingly fast, because now they're very static and there's a lot less work to do. And we can already benchmark those behaviors by basically pre-compiling from the first stage and then timing the build from there. And you can see, like, how fast would the build be if everything was V2, and it's nice, it's fast. Another benefit is that you can use dynamic import anywhere in your own code if you needed to. Like, it's a very powerful low-level tool that you can reach for. And you know, not just you as an app author, but library authors who want to bring in powerful capabilities. And automated route-aware code splitting is already a thing that's implemented. So you can give routes as split points, and we can split your code up automatically for you, and that's pretty powerful and nice. And lastly, you can import anything directly from NPM, statically or dynamically. This is a thing you can do today with Ember Auto Import in your apps. It's not a coincidence that you can do that. Ember Auto Import is really a polyfill for a subset of what Embroider does. The main difference is Ember Auto Import can only do that for non-Ember packages, for third-party packages that are not add-ons. It can't really do that kind of dynamic stuff, that kind of import of Ember packages, because there's too much existing, all of the existing non-defined, non-semantic stuff I talked about earlier. So Embroider takes you the rest of the way and lets you do it with all the packages, Ember add-ons, non-Ember packages, makes them standard. So the summary is that you get to keep moving forward on your app with no big app rewrites, and this is really only possible because of, like, the Ember's community values and the way we focus on bringing existing code forward into new paradigms in this layered way. Right? It's not a coincidence that we have this layered strategy for bringing code forward. It's the same way we've done many other successful things, like release Glimmer in the first place. We make a new layer that's nice. We make a nice new core. We add compatibility on top. And the critical step that people forget once they've invented a brand new core that they love is to go back and make the old things run on the new core. And doing that is so valuable, and that's what we've done successfully before, and we're going to do again. So that's the cool power of it. And I am done at exactly 40 minutes. So I didn't go faster, but I didn't go slower either. So we could still ask some questions, though. Yeah. This guy again?
Awesome talk. A few questions. First, at the end there, talking about importing from NPM packages. How does that? How those third-party NPM packages are published affect this whole thing? Because if you are importing Lodash and it's just like a UMD module from NPM or something versus DES,
right,
and having the benefits of static.
Yes. Right, so the spec says that we'll allow you to import either modules or CommonJS, because those are the dominant things. We make both of those work. And they're both basically analyzable enough. We can deal with CommonJS. It's not as static as modules, but it's pretty close. And in practice, the way people use Webpack and these tools is it basically works. There is more to it than that. Like, there's a couple other areas around rough edges. Things like which keys in package.json in terms of main browser module do you use and prioritize? We need to be clear on that when we specify these things. We need to give the switches that you might need to fix those things when people do weird things in their packages. And another big one is the spec. We've decided, like, when you import code, it's going to run through your Babel preset end. Like, we're going to make sure that if you said my app has to run on IE 11 and you import some library, we're going to make sure that if they use newer JavaScript, it's getting babbled. Like, that's just in there. There's an explicit opt-out for cases where you really know it doesn't need it, but that's another example of what happens when you import third-party stuff, where we do, like, to be precise about this and to not just accidentally swallow all the semantics of, oh, well, whatever Webpack does. we have to be pretty clear about what we support. And deliberately try to not support anything that's too weird. Because like the example I showed with modules working when they shouldn't, like code that works when it shouldn't is often just as bad as code that doesn't work when it should, in terms of locking you into things.
Lodash does publish a Lodash-ES.
Yeah, but it's also like what he said, which is like, what if the module is in ES9 or whatever, and you import it or something?
Yeah, yeah.
I was wondering, at which layer do you deal with dependency conflicts, or would you recommend providing
yes,
a hook
yes.
for dependency conflicts?
That's a good question. So one of the existing things about Ember CLI, I paused there because I was trying to say whether it was good or bad. One of the existing things about Ember CLI is that you really can only have one version of each Ember add-on in your app, right? If you needed to, you can't. And this does come up, right? If you end up using like a component from one library and a component from another, and they both have some shared dependency, but they need different versions of it, you're just out of luck. And there's like a strict version where you'd say, well, that's good because now you don't ship 2 copies of the library, but there's a correctness version where you say, well, but now you can't actually, there's no right answer anymore, you're just stuck, right? So when we follow what Node does for modular resolution, now it means you can have 2 versions. If like one add-on is trying to use version 1 of a thing and another add-on is trying to use version 2 of the same thing, you can have them both and they'll work and you'll get correctness again. Of course, that means you made your app bigger, and that's not great either. So often you can't solve that problem automatically, and attempts to do so really run against the cultural grain of NPM, which is all premised on like, oh, everybody should just have their own copy of everything. And because that's the cultural standard, if you try to flatten everything, you can try, and like Yarn has a flatten option, but you'll fight the system constantly because various library authors haven't done the work they need to express the broadest possible set of dependencies. A library might work with any version from 2 to 5 of its dependency, but it just says 5 because why would they bother expressing the full range? So you don't have the information you need to do automatic stuff. That's just the NPM ecosystem we live in. So we solve some problems, but we bring in others, which is that now like the classic NPM mess is now also still our mess, right? And so in terms of what layer to solve the problem at, I actually think is when you solve before you start the build tools at all. I think we need good linting and analysis and deduplication. And the nice thing about that is it's nothing Ember specific, right? Anybody who's interested in this problem, anybody working in NPM has the same problem. You want to run analysis to say, like, how many copies of Lodash do I have? Is there some way that I could reduce that, right? And can I use something like Yarn resolutions or other tools like that to flatten that structure down? The time to do that is like upfront before you've even booted this. And like once you go and boot the build system, we're just going to try to follow faithfully what the packages say they want. And if one wants version 1, one wants version 2, and they both find them, they'll get them. So in terms of where it fits like before all these tools entirely, which is I think is the right solution. It lets us not go and try to solve this on our own. It's a general NPM problem. I don't think that anybody's got a great general solution. We can certainly be the ones to make it, but it'll benefit all of NPM users and not just us. Yeah.
Hey, what does this mean in practice for add-on authors if I want to jump ahead to be V2 ready to take
Yeah, right. So, well, firstly, definitely, as I said, don't publish a V2 formatted package yet because we need to stabilize the formatting. If we change it, then you'll have a thing on NPM that's not standard. But the goal, of course, is to codify the standard to the point where it's safe to publish packages to NPM in this new format, and it'll last a long time. So that's part of the point of the spec, is to make it very stable. But before that point, though, there is stuff you can do to just be a better citizen of the ecosystem. One is, like, for example, don't try to escape your module namespace. If you do that, start to deprecate it and get your users off of that pattern. Another thing would be, and this is a little premature because the implementation of so the macro system I mentioned has an implementation, but it's a little behind on what the spec says. We're working on it. It's still alpha-ish. But as soon as that is ready, it's designed to be a regular Ember add-on that works in today's apps, today's Ember add-ons, and it works under Embroider. And what it gives you is a declarative way in your code to do the things that you might have done with very custom code in Broccoli in your add-on, right? So one of the early things we want to get people to do is we want to get that add-on stabilized and get it to the point where add-on authors can use it. Because the things that break add-ons is when they have custom Broccoli code that's deciding what to do, and just not needing that code it's nicer for the add-on author to actually just have a macro they can put. The way the macro system works is you can say basically like, hey, if the Ember version is less than 3, this code, otherwise that code, right? You can just say that in your code, and then the build system will do the right thing and only include the right code, and even include the right imports and all that kind of thing, so that you can do what would have been a custom Broccoli transform in your code. And that kind of a thing helps a lot. Like that gets you basically a long way along the way. Because now you got rid of custom code in the index.js of an add-on is the #1 reason you might break. Yeah.
I've got I'll go before Sam. You mentioned before that the LLVM IR was like really stable target to compile to, and that it's like standardized and common is the thing that makes it useful. Webpack is certainly really common. You mentioned though that we're maybe using like a subset that's not avoids most of the Webpack specific stuff.
Mm-hmm.
How stable do we think that is, and is it actually like a documented thing, or is it just implicit in Webpack's implementation?
No, so the subset we're supporting is really it tries to be very stable and documented, right? So it's the JavaScript has got to be ES latest. Anything that's been stabilized by ECMA is fair game in the JavaScript. Things like modules actually get into the app because rooted from the HTML, you need a script type equals module tag to get a module graph pulled in. Scripts that are in script context don't have a type module. Like that kind of a distinction is actually it covers an awful lot of the things that we think of as implicit today in Ember apps. We can express that stuff in spec language. It is very much following HTML spec, JavaScript spec. The things that are the only things we do that are beyond spec, and it's why I say it's only approximately code that would run directly in a web browser, is we do, for example, in terms of the timing of the stages, so the way I draw the picture, it seems like they must be very serial, first you do stage 1, and then you do stage 2, then you do stage 3. That's the data flow for sure, it's true. The timing though can be lazy, right? So you might not do some of the work in stage 2 until stage 3 realizes it needs something, and that pulls on the work that happened in stage 2. And in practice, what that means is stage 3 is going to have things it's going to be handed a Babel config, and stage 3 is going to be told when you see JavaScript, make sure you run it through that Babel config first. That lets us make all the Babel stuff be lazy, and so the Babel config is controlled by stage 2, but the actual code. It's stage 2 code that gets invoked by stage 3, right? So that little bit of a callback kind of thing is goes beyond pure web spec, being able to run this stuff. But it's a very small it's a very small kernel functionality that you could even implement just in JavaScript and run it in a web browser and do it all in the web browser if you wanted to have use the platform stage 3. So I'm pretty confident in being stable. To the extent that we find anything that's only works in Webpack, we want to literally forbid it and make it an error in a Babel plugin. Yeah.
Hello again. I feel like the stuff at the beginning of the presentation was really important to talk about, abstractions and thinking in terms of the input source. I actually feel like someone could argue that that's what differentiates people who believe in Ember and the Ember ethos versus kind of other ecosystems in JavaScript. And I also just think about, Tom and Yehuda's talk at EmberConf this year, where, we all believe in abstraction. I think that is something that distinguishes us, and we really believe in the power of shared solutions. And at the keynote this year, EmberConf, they talked about, kind of this up and down where you can go too heavy on trying to come up with the best abstractions, top down, too top down, and you miss some things, and you get 80 or 90% of the way there, and then you cause a lot of people pain or whatever, and you go down too much. And so there's this idea of, getting the primitives right, but then being honest about what we don't know and letting people experiment in user land so we don't get into these situations where we over abstract and box people in and just frustrate them when they're trying to do something we didn't account for. So kind of that in mind, again, as much as we all believe in the power of conventions and abstractions, you know, there's a lot going on here. So I guess, have you thought about that? Is that a risk with something as ambitious as Embroider? What are the alternatives? Or are we thinking about the best ways to integrate with the work that's going on with Rollup and Babel and Webpack and all these things?
Right, right. Yeah, so the danger when people describe over-abstract is usually really mis-abstract, right? Over-abstract, if it's possible to over-abstract, we blew that budget a long time ago, and people have probably heard me make this argument before many times. Like JavaScript itself is absurdly abstract from what actually goes on in microchips, right? So it's not over-abstract. It's a question of whether it's the right abstraction and whether whether it leaks rarely enough, right? And so it is very important that we pick abstractions that are robust and well-defined and that have enough buy-in, right? And so JavaScript is one of those abstractions, right? Like, so yes, to the extent that you can express what an Ember app needs just in things that are in the JavaScript spec, I feel very confident in that decision, right? And so that aspect of the design, I feel very confident in. You can argue, and some folks probably would argue who are not in the Ember community, that, well, like, the thing a compiler would have written at the end of stage 2 is what you should have written by hand, right? And honestly, that's the same kind of knee-jerk reaction Grace Hopper was getting in 1952. It's been the same way all through computing. Like, it's true that like the first versions of each layer of abstraction are not perfect because they're the first versions. And so it's frustrating enough that people say, like, this isn't worth it, write it by hand. They're always wrong eventually, right? It's just a question of how long it takes. So you're right that is, like, in terms of where's the technical risk in a project like this, it is that, yeah, like, you didn't get far enough and the abstraction is bad. On the other hand, I don't think this is adding any new technical risk because the input abstractions we're dealing with are the ones we have. I didn't set out to create them. I set out to discover them, and it's been quite an interesting journey of finding them all, right? Because the goal is to take all the existing semantics that are out there and capture them into a new, more narrow abstraction, right? And so, even if there's a mistake we've made in the past, this is mitigating it and not exacerbating it. So, in terms of technical risk, I feel very good about the decisions in the design, in terms of not misabstracting. Yeah.
Wonderful. That is a great note.
I have a wrap up then.
Please do.
Okay, and I'm here with my son Quint.
Hi, Quint.
He's EF5. I'm EF4. That's not even just a joke. That's literally his name. Because my name's Edward IV. He's Edward V. That's why he's Quint. He's here with me. I asked him if he wanted to give a lightning talk tonight. He declined. But his counter suggestion was that I should share to you a fun animal fact. And he chose the animal fact that horned lizards can shoot blood out of their eyes to scare off predators. Whoa. I'll leave you with that thought.
That's good. All right, thank you all very much. I think we're a little bit late, so I won't suggest that we head to the pub, unless lots of people want to go. Oh, Aaron wants to go. Okay, Sam wants to go. Okay, yeah, then I have a pub, so I'll give us the pub. But yeah, thank you very much for coming out. Thank you, Ed, and thank you, Chris, out of towners, and Hassan.